My name is Paola Puche, and in this video I'm going to be explaining how to find the tensions in ropes 1 and 2 from this diagram. The first thing necessary is to find the force of gravity in the diagram. In order to find this, we will use the equation mass times gravity equals force of gravity. The mass in this equation is 10 grams, and gravity will always be 9.8. This gives us 98 as our force of gravity. The next thing we need to do is break up these two sides into separate triangles. So rope 2 will have a triangle like this with x2 at the top and y2 at the bottom, x and y directions, and the second rope like this. Sorry, the first rope. With 50 degrees and 30 degrees. This will work as your coordinate system. Once you have that, you can divide it into your x and y components. In the x direction, you're going to put in this equation. F force of tension from rope 1 minus force of tension in rope 2, because this force of tension in rope 1 is positive because it is going to the right, and force of tension in rope 2 is negative because it's going to the left, will be equal to 0. Now you will plug in force of tension 1, you will put Ft cosine 50 to replace the x, and in force of tension 2, you will put cosine 30 to replace x2, and this is equal to 0. Now you want to isolate ft1, so you will divide cosine 50 on both sides. So you'll be left with ft equals ft2 cosine 30 divided by cosine 50. Now you will leave the x direction on its own, and you will move on to fill in the y direction. Here you will use the equation ft1y plus ft2y. Here they are both positive because they're both going up. Now you will do minus force of gravity. The force of gravity is always a part of the x direction. That is equal to 0. Again, you will plug in, but this time instead of using cosine, you will use sine, since they are opposite the angle instead of adjacent. So ft1 will equal sine 50 plus ft2, which is sine 30. Now you will pass the negative 98 to the other side to make it positive. Once you reach here, you plug in the equation from the x direction, and you put it into the y direction. So you are left with ft2 cos 30 times sine 50 divided by cos 50. And you put this in parentheses, plus sine 30 is equal to 98. You put this whole equation in the calculator using the parentheses, and it will give you ft2 1.43 is equal to 98. To isolate ft2, you divide both sides by 1.43. So your force of tension in rope 2 is 68.53 newtons. Now, in ft1, to find the x direction, you will plug in this number. So this equation will be 68.53 cosine 30 over cosine 50. You will use the parentheses again, and ft1 will equal 92.33 newtons. Now we have found the force of tension for both ropes 1 and ropes 2. So your final answer, you must include the direction in which the tension is going. So it'll be, so for rope 1 equals 92.33 newtons, and the direction is y 50 degrees x. For rope 2, it equals 68.53 newtons, y 30 degrees x.